A tank with a square base of area 1 meter square is divided by a vertical partition in the middle. The bottom of the partition has a small hinged rod of 20 centimeters square. The tank is filled with water in one compartment and acid of relative density 1.7 in the other, both to a height of 4 meter. Calculate the force necessary to keep the door closed, and gravity equals to 9.8 meter per second square. So yes, this is the case. So there is a vessel and we have water one side and acid on the other side, and separated by a compartment in the middle, and at the bottom of the compartment we have a small door which has the area of cross section, I think as it is 20 meters, so 20 centimeters square, and the water and acid both are filled up to the level of 4 meter. Now we have to find the force necessary to keep the door closed. Now please see, because of water there will be a pressure on this door, and because of this acid there will be another pressure on this door, and both these pressures will be acting in the opposite direction. Because of water the pressure will be in one side, and because of acid the pressure will be on the other side. So now we have to calculate the pressure due to both water and acid, and we are going to subtract okay. Then we are going to find the force, and we will find in which direction we should apply the force now. Now let us see what is the pressure because of water. It is H into rho W into G. So 4 into 10 cube into 9.8. So we get an answer. And the pressure exerted by the acid is H into rho A into G. So again 4 into 1.7 into 10 power 3 kilogram per meter cube. So they have actually given 1.7 as the relative density of acid. So the relative density of acid, that means rho A by rho W is 1.7. So what will be rho A? It is 1.7 into rho W. So 1.7 into rho W is 10 cube. So that is the reason we have taken the value of rho A as 1.7 into 10 cube kilogram per meter cube, and the value of gravity is 9.8 meter per second square, and we get an pressure for acid. So the value of pressure for because of water is 3.92 into 10 power 4. While you take the pressure because of acid is 6.66 into 10 power 4. So yes, pressure because of the acid is more than the pressure of water. Now what is the net pressure on the door? So pressure because of acid is more. So pressure because of acid minus pressure because of water. So that is equals to 6.66 minus 3.92 into 10 power 4. So it is approximately equal to 2.74 into 10 power 4 Newton per meter square. Now this is the net pressure. Okay, if this is the net pressure, and we know what is the area of the door, and it is 20 centimeters square, that is 20 into 10 power minus 4 meters square. Now I have the value of net pressure and area. From this I can find what is the value of force. So force is pressure into area. So here it is net pressure into area. The net pressure is 2.74 into 10 power 4 Newton per meter square, and area is 20 into 10 power minus 4 meters square. So I get the value as 55 Newton. Okay, so now let us see. This force is directed from acid towards the water. Hence, to keep the door closed, a force of 55 Newton should be applied horizontally on the door from the compartment containing water, so that to that containing acid, the base area of the tank does not affect the answer. So please try to understand this clearly. So because of the pressure exerted by water, the force on the door because of the water will be in this direction. Okay, because water tries to open the door and it tries to go that side. And if you take the acid, because of the pressure of acid, the force on the door will be in this direction. Okay, towards the water side, because it also gives some pressure, so that the force acts and it will try to come outside. So the force will be in this direction. Now, as the pressure because of acid is more than that of water, if I am leaving just like that, then this door will open and acid will try to come out. Okay, because the pressure due to acid is more. Now, in order to stop that, what I have to do, I have to apply the force, that force which is to be stopped in the direction towards the acid. Okay, so please try to understand, this force is directed from acid towards water. Hence, to keep the door closed, I have to apply a force equals to 55 Newton on the that should be applied horizontally on the door from the compartment containing water to that of containing acid. So this is what is the case. So this is the answer, and the base area of tank does not affect the answer. Okay, I hope you understand this one. Two vessels have same base area but different shapes. The first vessel takes the twice volume of water that the second vessel requires to fill up to a particular column of height. Is the force exerted by water on the base of the vessel the same in two cases? If so, why do the vessels filled with water to the same height give different readings on the weighing scale? So please see, we have two different vessels which have different shapes, and but we are filling the height to the we are filling the volume of water, sorry, we are filling the level of water to the same heights in the both the vessels. But if you see here, it occupies twice the volume than that of this one. So because you can see the volume of this vessel is more than this vessel, but the height of the water column is same. So the first question is the force exerted by the water on the bottom of the vessel same or not? So that is the first question. Now we know what is the pressure because of the height of water column, and it is H rho G. What is it? It is H rho G. So it is dependent upon height, and it is dependent upon the density of the liquid. So here height of the liquid is same in both the cases, and density of the liquid is also same in both the cases. So what will be the pressure? The value of pressure at the bottom will be same because of these two cases. The value of pressure is same because of the two amounts of liquid. Now you see, and it is also given that the base area of the vessel is same. If base area of the vessel is same, then I know force is equals to pressure into area. Okay, so the value of pressure is already same and value of area is same. So the force will also be same in the both the cases. Okay, I hope you are getting it. Now let us move to the second question. But why do they give different readings in the weighing scale? That is the second question. The water exerts force on the walls of the vessels also. This force F is normal to the side of the vessel and has no vertical downward component for a vessel like B. But when the sides of vessel are not normal to the base, as in vessel A, the force F has a non-zero vertical downward component. Hence, vessel A gives a higher reading than vessel B on a weighing scale. So, the water exerts a normal force, that is the force which is perpendicular to the surface. Okay, in this case the perpendicular is like this because this is the surface and this is the perpendicular, and this is, in this case, this is the perpendicular to this one. This is the perpendicular. So if you see this one, this has two components, but if you see this one, this has only one component, and here you have two different components. So because of this non-zero downward component, this vessel A will have a higher reading. During blood transfusion, the needle is inserted in a vein where the gauge pressure is 2000 Pascal. At what height should the blood container be placed so that the blood may just enter the vein? The density of blood is 1.06 into 10 cube kilogram per meter cube. So here we have the value of pressure 2000 Pascal, and the density of the blood also we have, and we should know what is the value of height. Okay, so we are requested to find the value of height. So H rho G equals to pressure. So we have the value of rho and G. So it is 2000 by rho G. So 2000 by, what is the value of rho? It is 1.06 into 10 cube. Value of gravity is 9.8. So that is the answer.